Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4, and today we're gonna present about mathematical modeling of exponential population growth model in Oman from 1917 until 1980. For this slide, table of content of this slide, first of all we have introduction, and then implementation, data analysis and discussion, conclusion and recommendation. Okay, for introduction, this task involve the application of first order differential equation to study the population in Oman between 1970 and until 1980. The initial model, known as Malthusian, was developed by Thomas Malthus in 1978 to analyze and predict the human population growth. And here we will utilize the model to examine the population trend in Oman during the specified period. So the objective of our task is to assess the accuracy of the Malthusian model in predicting Oman population. And secondly, we will predict the future population of Oman, and finally we need to predict the population of Oman in the past.
For the implementation, secondary data used in this task represent the population of Oman from 1917 to 1918. We obtained it from the website called World Data Bank. Based on this table, we can see that as the year increases, the population also increases. Next, the integrate equation is used to calculate and analyze the human population growth in Oman from 1917 to 1918. This is our formula and equation that we will use and will be explained in the next slide.
Next is to find the particular solution. So first step is to separate the variable p and t, and we got 1 over p dp equals to k dt. Second step is to integrate both sides of the equation, where we got p equals to e to the power of kt plus c. The third step is to simplify the general equation, and we got p equals to e to the power of kt, where ec is a. And then to find a, we need to let t equals to 0, which refers to 1970, and the population is 670,693, and just substitute the value into our general equation, and we got a is equal to 670,693. General equation becomes p equals to 670,693 e to the power of kt. Number 5, we need to calculate the k, which is the constant, and we need to use t equals to 1, which refers to 1971, and the p is 688,803, and then we substitute into the general equation and we obtain k, which is 0.027, and the particular solution becomes p equals to 670,693 e to the power of 0.027 t.
Next, we move on to data analysis and discussion. This is our actual population graph of Oman that we have obtained from World Data Bank. As we can see on this graph, we can see that this graph is slightly exponential from 1917 to 1918. And this is our estimated graph of population in Oman that we obtained after we derive it from Malthusianism formula. And this is our graph of comparison between the actual and estimated population of Oman. As we can see from the graph, that the graph reveals a steady increase in the population of Oman over the years, and it is proven that our specific solution is closely approximates the real population data.
For the prediction of future and past Oman population, we have used the particular solution equation to predict the estimated population in the year of 2000 and in the year of 1960. For the year 2000, we use 20 as the time interval for the year 2000, and we insert t equals to 20 into the equation, and we have obtained the expected population in 2000 is equals to 1,150,914. For the past population in 1960, we use the same equation, which is the particular solution equation, and we have used -10 to indicate the year of 1960, and then the -10 value is inserted into the equation, and the expected value of the population in 1960 that we have obtained is equals to 511,993 population. For the percentage error, before we start to calculate the percentage error, we are required to find the average of actual population. So we add all the population from all the years, which we got 8,921,776, and we divided by 11, which is the time interval for our population, and then we got 811,071 population. So, and then we are required to find the average of estimation population, which we got 8,474,771, and we divided with 11, and we got 770,434. From that, we use the percentage error equation, which is the estimated value minus with actual value divided with the actual value itself, and then multiply it with 100. And by that, 770,434 is minus with 811,071 and divided with 811,071 and multiply it with 100, and we got 5.0%. Sorry, 5.01% of the percentage error.
Next, difference between actual and estimated population. The number we calculate using the particular solutions method is different from the value reflected in the actual data due to the time interval values used for the particular solution are consistent with t equals to 1, 2, 3, and 4. While it is for the actual population, it is different because the birth of current humans cannot be controlled because the human birth rate is different throughout the years and months. Next, reasons growth. First one, high fertility level. Fertility levels in Oman have stabilized at a high rate of over 8 births per woman. Such high fertility rates could result in a population surge in Oman due to the sharp increase in birth rates. Next, migration. The data shows a significant increase in the proportion of net migration since 1970 in Oman. This growth can be attributed to Oman's expanding economy. Similar to other oil-rich Arab Gulf nations, the influx of people seeking job opportunities and improved living conditions has led to a rise in population through migrations.
So, for the conclusion, Task 1's goals were met by using first-order differential equations from the M8099 course. We calculated Oman's population growth from 1970 to 1980, handled percentage errors, and identified factors affecting the data comparison. Moreover, we explored the reason for the population growth and applied mathematical techniques like the Malthusian model to solve problems practically. For recommendation, Task 1, which is the population growth in Oman from 1970 to 1980, we found that the actual data is not the same as the calculated data. Thus, we would like to recommend that we need accurate data in order to obtain an accurate particular solution. This will make us able to predict the Oman population with higher precision. So that's all from us. Thank you.